How's everybody doing? Doing great? All right. What are we at? We're a little bit after lunch. People want to get up and do a little bit of a stretching exercise? All right, good. I won't make people do that. Okay, so let me get started here. Just let me go through from the talk here. I'm putting kind of a idea that people have heard a few times in crypto, which is that we're going to want the cloud to come to crypto. I'm hoping by the end of the talk you'll see that there's actually a vision here that kind of makes sense if you're a Web2 developer looking at like what that in fact could be. And if you were coming here to hear about EigenLayer, because I'm the head of the EigenLayer Foundation, then you might be thinking, oh, I've heard EigenLayer is about restaking, it's about financial protocols and others types of things. And there are definitely financial aspects. But when you're looking at why we're doing what we're doing, this is sort of the big point here, which is making blockchain services more and more accessible to technology developers to build faster, build better, and build bigger. So with that, let me kind of kick in here. So one of the key ideas when you get to this concept of restaking is that you take assets that already exist in crypto that are very plentiful, like Ethereum, like the token attached with your protocol that has hundreds of millions or billions of dollars worth of value in it, and you allow it to be reused. Not for like Aave or Compound, loans where you do something financial with it, but you do something else that's actually like a work function, which is you use it as a slashing collateral for additional services. And so, you're not taking out money against it, but you're giving yourself the opportunity to make money against these assets. You can actually take them and use them for additional cloud services and so forth. So I'm showing a canonical path here, which is ETH token. I'm going to break it down into two steps. And one thing I should say to everybody, when you're looking at this and you're seeing ETH token, of course, there's a huge capital asset pool inside of Ethereum. But if you've got your token, whatever it is, I just saw Ed Felton was here, imagine ARB token, you can put that in exactly in the same way as the ETH token. So I'm breaking this up in... I'm going to start just walking with this here, so I'm finding it annoying to lean into it. I'm going to break it into two steps. The first step when you're looking at Ethereum, oh, even better, thank you. Hello. Okay, so the first step when you're looking at Ethereum, inside of the regular kind of canonical path that we're all familiar with, you take the Ethereum token, you put it into the consensus protocol of the beacon chain, and then that runs the EVM, and you set up smart contracts. Those run your dApp protocol for on-chain, and then this is your dApp over here. And, oh, crap, I was giving these slides yesterday. I told myself I was going to fix this graphic. Okay, let's just say your dApp happens to be a wavy graph up to the right. Okay, obviously you have a more interesting dApp than this graphic shows. Okay, so that's the regular Ethereum path. The key insight, 2.5 years ago, Shriram came up with something that was actually kind of hilarious. Some of the best VCs in the space 2.5 years ago said he was nuts. This was a terrible idea, and now you see multiple protocols are actually copying us. Everybody's just saying this is the best idea ever. This is going to be a massive unlock in crypto, so, go us. We were right. You take the ETH token and you actually restake it. So you take it from where it is, which is in validator contracts, and you put an extra slashing condition on it, and you put it into new consensus pools. So each of these new consensus pools is exactly the same like being a validator on Ethereum, except now you're running a different protocol. You're running a protocol that's doing something on file services, doing something on computation services. It's doing something on human trust services, whatever you can imagine in blockchain, but you don't have to go out into the world and raise a whole bunch and waste a whole bunch of money just pumping up a token way before you're ready. You can actually get all the security you need. So, you think about why did something like the public cloud become so popular versus buying your own servers is, you spend $10 million to buy a whole bunch of GPUs and servers, or you spend $100 and you have them accessible to you for an hour. So the idea here is you can actually just buy and pay for the security you need when you need it, and you don't have the huge friction flywheel of having to figure out how to get your token up there. Plus, if your token is varying in price and other things, it can be quite risky. So, and of course, you can mix your token in any way you want. But so these AVSs are all functions. You can imagine them as like, your version of Ethereum doing what you would want it to be doing. And then you offer them as services to the dApps that are out here. So people who are building dApps now see they can run smart contract EVMs on Ethereum. They can run computation services. They can run identity reputation services. They can run storage services. This basically starts looking like a cloud of middleware, okay? And you look at different categories. Like right now inside of the blockchain world, we have a lot of roll-up services. And so we're talking with, and a lot of the major teams that are doing bridges, MEV services, watchtowers, decentralized sequencers. You can just connect to these, and all of these are completely accessible within a common cloud framework. So you can see the vision. Here, I'm going to go forward and then back again. Is, oh, we did not get the new slides. Oh, well. I had one other slide over here. The vision is like, if you're familiar with the infrastructure as a service, platform as a service, software as a service kind of stack up when you're looking at a cloud. These things here are these X as a service functions, except now they're all plumbed together and they're tied back to crypto rails. So you can put crypto security and crypto payments in them. And you have different categories, coprocessors, cryptography, proofs, again, like I was saying, a lot of stuff around data, databases, load balancers, networking, identity reputation. Everything that's kind of in there that you would expect in a cloud development framework is now being supercharged with blockchain and under a common security framework as well. So you don't have to hodgepodge together a whole bunch of different things with different security trust parameters. And at the base of it, the Eigen layer shared security system is bringing in all of the token security that you need. We also have a couple of important services. Everybody here has probably heard more than they want to hear in their lifetime about data availability. Something like that is super important. So we have that built into the base of the system. Certification, signatures, those types of things. And when you're building these types of systems, it's really important you have a lot of capacity. So I did want to highlight one specific feature here, which is you look at something like data availability. You have improvements that are happening in Ethereum around 4844, around donk sharding. We're actually building things for extremely high capacity. So Eigen DA right now is the best-in-class version of DA that you can get out there. And we have a scaling roadmap for hundreds of times more in terms of capacity there as well. And if anybody wants to look, there's a lot of technical information available on it. But I would say that, I would say in general, think about it this way, that you've got gigabrains that are working on some of the most amazing information technology, so you don't have to. You just plug it together with the app that you're trying to build. So I said the statement about this is actually better and fundamental. I did want to throw in, if you take a look later at the slides, we're not talking about a little bit better. We're actually talking about the DA being orders of magnitude more efficient, more effective, and more scalable than what you can get from other DA that's out there. And that all translates to more capacity and lower fundamental cost and better scaling over time. So why does this matter? And that's because when you look at actual applications, the way people are building, nobody starts from the ground up and just writes Rust and then compiles Rust and they're done. What you actually do is you take as many pieces, oh, hi, Grigori. You take as many pieces as you can from all over the existing world, you integrate them together, or you even get a cheat code and you take other people's framework. It's already almost 99% built and you add something. Why do you do that? Because why would you want to redevelop something that's already production integrated, production capable? So the important point is making sure that applications today, the Web 2 applications, are able to move over to Web 3. And sometimes people think, oh, well, the scale of this is, it's big, but it's not too crazy. And the reality is it's crazy. This is just Google Cloud, and this is a subset of all of the SaaS services they offer. Almost everything on this list, they didn't actually write. This is software other people wrote in the open source community, and they've co-opted it, put an interface on it, and they're selling through Google Cloud. Amazon Web Services has the same thing and more. Azure has the same thing and more. The vision I want you to think about is everything in here running on crypto rails. Everything in here being accessible to you as a blockchain developer when you're next building something. Everything here, if you're somebody in the infrastructure space, being accessible for how you can make money with your compute, with your storage, and so forth. So, pretty ambitious vision. You know, a lot of steps to get there. You know, if you're interested, come see me afterwards. If you're interested in partnering, we're hiring like crazy. You know, everything else. This is another view. I like Google actually puts different views of all their middleware. This is something that you can click on. It's like a two-dimensional graph. This actually goes on for like 10 pages. It's pretty incredible, the amount of like what is Web 2 right now. This is what we have to get to in Web 3. This is table stakes. People who are developing software applications, when you're looking at, you know, the dominance of OpenAI, you're looking at the dominance of the centralized systems out there, we got to be sure that we're ready for this kind of scale. And that's what Eigenlayer is going after. That's why when people look at it and they say Bitcoin, then Ethereum, then Eigenlayer, you know, Eigenlayer is that fundamental, the shift of taking security, putting it in a framework, making it the kind of collateral cost needed, giving it the right structure that you can actually do this, and doing it in a way where we actually control almost none of it. We're just creating a thin little piece of infrastructure that allows every open source developer in the world to have a capability and capture 99.9% of their value. And the same thing with hardware vendors and everybody else. So we're doing it the right way, the Linux way, which is open source and the developers own everything, and crypto just allows you to glue it together into something of value. So, and one final thing is sometimes people, when I'm doing these talks, they're just sitting there and they're thinking in their head, I don't understand this. Public clouds are already decentralized. Why do we need to decentralize them? Most of Web3 runs on Amazon. That all seems totally fine. Of course it's fine because, you know, Amazon is decentralized from an architectural level. But if you go back and you look what Vitalik has said in the past, a really key point is that there's different types of decentralization. The most important decentralization aspect is actually not architectural. It is governance. It's political. It's who are the shareholders, who actually owns and runs the company, who is going to decide how we take the value out. Why do you end up with Google AdWords and things having 45% margin, where they're taking that cut off the top, or the Apple Store taking 30% when it should be taking 3%? It's because once you have somebody in the middle who's centralized, owning the billing system, owning the integrations and so forth, at a certain point they flip the switch from free to really expensive, and you can't leave because you're already stuck in the system. I feel like I should knock the last one down, but anyway, okay. My head is in the clouds, not looking down at my legs. So, so the reason, and everybody in the Web 2 investor space knows, you know, look decentralized, have a centralized capture mechanism, get a network effect, and then once you've got everybody in the system and you have the network effect, just go ahead and start extracting. A couple of years of free, and then everybody pays down the road. The reason crypto is amazing, we're building everything, open APIs. If we wanted to extract down the road, people would just fork our protocol. So, you know, it's that whole thing that people have said in the past, but if you haven't heard it, I always thought it was a clever one in crypto of, instead of, you know, don't be evil, can't be evil, right? So when you integrate together with this, it's sort of the reason we all went to open source. You know with open source, nobody's going to screw you over in the end. You know with proprietary software, people always do. So the billing system, the provider access, and who earns the value, them being centralized. People can only bring servers in if Amazon says so. People can only attach and put their software into the system and sell it through Amazon if Amazon says so. If Amazon decides that they're going to capture value off your software, there's nothing to do. And this is a really important slide. This is giving you the 40-year history of software in 3 little bubbles. The left bubble is before the cloud. Everybody said, hey, we're going to create open source software, Linux, everything. People are going to deploy it on their own hardware. Everybody's making money in the right order. This is where we are now. The public clouds came out, and people realized that you would take an open source project. The poor software vendor is hoping that you're going to run their software on the cloud. That's not what Amazon and others want to do. They take the open source software, They do an Amazon Elastic DB, Amazon, load balancer, whatever else, and they offer something with 80% of the features for free or at a marginal price, and then they're making money a second time in the hardware, software, and other things. So this forked value capture means the person who's actually making the money, a lot of the money, and putting none of the investment back in, is not the principal who created the software. And that, unfortunately, both means that money's going to the wrong place. It also means that almost everybody in this room who's a developer is having your bread, your actual food at the table being taken by somebody else. Seems unfair. It's also very inefficient. We would actually have a lot more innovation happening if the money was going back to the developers and back out to the decentralized community. So that's what we're getting to with the crypto cloud. So, again, this is it's interesting. I think for a lot of people, when they come and hear me talk about EigenLayer, it's a little bit surprising to them. This isn't what they expect to hear. I'm from the infrastructure world. I spent over 2 decades in Silicon Valley building software, hardware systems, other things. This is actually why I'm in crypto, is to make this transition happen. So you take open source software and you get back to something that's a little different than the original one. You still don't have private infrastructure. Private infrastructure is expensive and it doesn't scale. You substitute it for a decentralized physical infrastructure, for a decentralized public cloud. How come there's not a fork here? Why doesn't the decentralized physical infrastructure in the cloud capture the value? Because there's no platform risk. None of these providers, 100 different providers giving you different types of hardware, different services, they're not going to end up being Amazon and try to fork all the software value from you. You're on an equal footing with them. There are other crypto companies just like you. And so in the dApp, they get their fair share. The dApps pay them for the cost of the servers and everything else that's being run, and the open source software gets the money that they deserve. And so we come back full circle. And so, if we're successful, I think everyone sitting in this room is going to have, 10 times more money than they would in an Amazon world, and be able to create your own software companies and everything else. So we're really hoping that, the amount of value EigenLayer, if we end up being a successful protocol, then across the crypto space, there's going to be 1,000 times more success. That's really the vision here. And in some sense, that's the reason why I feel like we're as ambitious as some of the original crypto companies out there, because we're looking at having so much value that is going to be shared all over the space. It's much bigger than our protocol alone. So one final slide I'll just leave on here, because I went through so many different pictures here. But I do want to hit a couple of points here, because I never actually talked about shared security. This is a point I just really want to drive home. I'm actually not going to talk about too much else in this slide, although you can take a look at it. We have really clever crypto protocols around attributable security and some other things, but it's too much for this talk. But the first one is, why does something like Ethereum work so well? Because all the dApps are in the same security framework. If Chainlink fails, then Uniswap fails, then Aave fails, everything fails at the same time, or everything works at the same time. So we have all of our eggs in the same basket. Sounds scary at first, but then you realize, yeah, but that's the reason why we can have $50 billion of security on Ethereum, because everybody's collecting their security into one common pool. All of the dApps have it. In a sense, if you want to think about it, in addition to have composable atomic transactions, you have composable security inside of Ethereum. And so what we're doing on the middleware space is we're taking Ethereum, fusing it together with assets of any possible token chain that's out there, putting it into a shared security pool, and allowing that to be available to any protocol that somebody creates from day one on an on-demand basic, elastic shared security. And you just take an example, we are going to get to, I know we're going to get to thousands, even tens of thousands of software projects. Why? Because there's millions of developers, and people don't want to work in 100,000 person companies. They want to work in smaller companies where they have the lifestyle, they get to live where they want, they get to do what they want. But with EigenLayer, we won't be piecemeal fighting against Web 2. We're going to be collecting together into common base layers. Common security on Ethereum, on Bitcoin, on EigenLayer, collecting all of your tokens, putting it together. And instead of having $1 million across 1,000 different services, we allow you with EigenLayer to collect that all into $1 billion of security across all of them. Or scale those numbers up, put $100 million here and make this 100,000, and you're getting up into the trillions of dollars of security. So together, Web3 is an unstoppable force because the network effect is all of us combined. And that's something that individual companies in Web 2 can't compete with. So I'll close there.